The world's oceans cover 70% of the Earth's surface, the largest natural system around us. Oceans are also the largest removal mechanism for carbon dioxide from the atmosphere. The oceans absorb about 30% of all of the carbon dioxide that we emit into the atmosphere. But the absorption of carbon dioxide is very problematic because it causes ocean acidification. When you think about really large-scale problems, you need really large-scale solutions. And since time of the essence, the coupling of an engineering solution to a natural system is the only way that will bring a significant solution. My name is Gaurav Sant. I'm the Pritzker Professor of Sustainability at UCLA, a co-founder of Equatic, and I'm going to show you how we're going to remove carbon dioxide from the world's oceans and the atmosphere using the Equatic process. I grew up on the west coast of India in a state called Goa. I spent lots of time on the beach, taking many walks with my father and my sister, collecting seashells. So I've had a bit of a love affair with seashells my whole life. Seashells are made of calcium carbonate. Little critters in the ocean actually make seashells as a part of a biological process. Seashells are actually a means of locking carbon dioxide into a solid in a really stable form. And this is indeed what we were inspired by. The question that we really set out to answer was, how do we allow absorption and storage of carbon dioxide on the oceans while reversing the effects of acidification? And we realized that electricity in a well-known industrial process known as electrolysis could be used to do exactly that. And so what the process allows you to do is to use a simple electrical transduction to remove carbon dioxide not only from the world's oceans, but also from the atmosphere, allowing net carbon dioxide removal. When we first started working on the process, we did a series of laboratory demonstrations to show that indeed this did work.
This is a small-scale representation of what is meant to be out in the field, and this is a giant tank of simulated seawater. This helps deepen our understanding of individual components and the reaction itself.
What took us a really long time is to figure out how to transform that into an engineering process.
The barge is a whole new engineering challenge altogether.
We went from a laboratory system to building pilot plants. We achieve all of our carbon removal inside an engineered plant. It does not actually happen out in the ocean. We have both the ability to effect a process really efficiently within a closed system, but also exactly measure how much carbon removal occurs within that system.
Should I remove my gloves?
I met Erica in 2017 when she first started working at UCLA.
Erica, take 4.
She's probably the most talented scientist I've met that does what she does.
My name is Erica Laplante. I'm co-founder and head of measurement, reporting, verification, and environmental impact assessment at Equatic.
That is a big job title.
So the process is really designed with MRV in mind. We've engineered the process. So for example, we do equilibration, we do the carbonation within the plant. That entails some energy, but then the trade-off is that now we're sure we could accurately measure our carbon removal within the plant itself. It presents a means for durable storage of CO2. So all of these aspects makes it a promising route for gigaton scale carbon removal.
Now, the nice thing about splitting water in this particular manner is that you produce hydrogen. And so if you imagine a transition away from fossil fuels, this is where hydrogen turns out to be really important, because hydrogen is not only a valuable co-product because it's a fuel, but importantly, it's a clean fuel. And so rendering affordability, accessibility, and the ability to deliver at enormous scale all have to go hand in hand as we achieve carbon removal and hydrogen production both using seawater directly. So this has been a long-standing challenge, one that now we've managed to solve. It exactly mimics and replicates a natural process. It just accelerates it. We are building a large demonstration plant in Singapore. The plant will do about 4,000 tons of carbon removal a year, produce about 100 tons of green hydrogen, which really set us on the pathway to build yet bigger plants. Its ability to scale is enormous. What is nice about being a professor is that you have the ability to be creative, you have the ability to transmit knowledge, but you also have the ability to create new knowledge. I think it's particularly important that we keep our children in mind, because these effects are only going to get worse if we don't do something about them. My daughter is 8 and she doesn't understand the technical details of what we do, but I think she's very familiar with the idea that climate change is something that is ongoing. I think it's undoubtedly true that children make you have a much deeper and a much broader perspective than you would have otherwise.
It looks so beautiful, the ocean.
Yeah, it is. It is indeed, darling.